And with that, the streaming starts. Hello, anybody who happens to be around. I just posted it to my Facebook, so who knows? Maybe somebody comes around. I have no idea how the audio quality is. This is my first time using OBS, and I've got my extra monitor over here, so I'll be looking over there. But what you should be seeing is me and X-Plane 11, which is paused. And we are paused. Oh, I need to click on that. No, not on that. Oh, bother. There we are. Alright, so this is the map, and the purpose of this video is for future students, if they have any trouble with DME Arcs and other YouTube videos don't quite cut it, then they're welcome to watch this. This is how I'm going to teach DME Arcs. So first of all, you've got to put yourself in a place where the DME arc is going to happen, and let's follow along with the DME arc itself. I'm going to open, there it is. So this is flight service 1-800-WXBrief.com. So if you type that in, or if you call that phone number, that's how you can get a weather briefing or file a flight plan. But it's much more useful online, in my opinion, especially for the fact that you don't actually have to have an account. You can create an account even if you're not a flight student or have any credentials whatsoever. But what I want to do is come up with something so you can follow along. There's the map. Oh, I wasn't expecting a line of thunderstorms. I guess that's outside. I'm in Round Rock, which is, oh, I guess it already passed by. Okay. So that's College Station, and it's a pretty popular location for flying to happen. What I want to do is find that, and if you aren't sure where it is, go up to the search term CLL and type that, and there it is, CLL. You want this, which is the little airport on the right. Right-click that, and then you have a little a hot dog menu, I think. Click that and click Airport Info. And this is everything you could possibly want to know about College Station, unless you're an Aggie and you want to know even more. So we come down here to the ILS or Localizer Runway 35. It's the first one in Section 2, Instrument Approach Procedure Charts. We click that, and this opens up. Now I'm also going to zoom out so that it fits on one page, and so that we can talk about it. So there's a couple of different ways of flying this approach. This here is the airport, and that's runway 35. And there's a little arrow saying, hey, this is where you're going to enter the runway. Got runway 29, runway 11, runway 17 on the other end, and then this runway and that runway are both closed, but they were in use at some point. So this goes to 3.5. So this big picture right here is this little tiny bit. So this is where we're going, and this is where we're starting. Now you can start in a couple of different places. You could start over the nav aid and then come out here and do a little turnaround. We'll get into that in a different lesson. You can go straight to here if you've got a GPS, and then dogleg over and get onto the final approach course. The main thing you want to be able to do is get on that final approach course. And the methodology for doing that, unless you have GPS, is we call that a course reversal. In fact, if you look at an actual GPS approach, this is the same approach, basically. Goes to runway 35 as a final approach fix. Oh, how can we zoom out? All right, fit to one page. So for this one, you don't have to do a course reversal because you can just go straight to this waypoint, Eteo, Jotad, and then Gucci. I guess that's how you probably say it. Easy. Go here, you turn left to 076, turn left to 346, and you land. That's easy enough. Here, you don't really do that. because this is not based on GPS, it's based on ground-based navigation aids. So if we wanted to do it all ground-based, you'd need a little beacon here, a little beacon there. Then you got to talk to whoever owns that land, allow them to get them to allow you to put that up, and then there's electricity costs for transmitting and maintenance costs, all that other stuff. So how do you get on the final approach course? Well, you can either, if you have a non-directional beacon, automatic direction finder, you can tune that 260, navigate direct to that, and then track outbound the 346 with 110.55 in your VOR radio. Track that outbound and then make a turn 45 degrees and then another turn 180 degrees, re-intercept and come in. If you don't have that, you can fly over the College Station VORTAC, go direct from any direction, then turn to track the 139 outbound when you get to 7.9 DME, or you cross the localizer course, then go out, do the procedure turn again, come back in. You come out here, you track, you follow those instructions, 291, 4.4, and then 346. It says no PT, which means no procedure turn. Or you can do this, which is the arc, and that's the subject of this video. So we're going to do the arc. So as you can see, the arc starts at Ozumi, which is the 249 radial. It's 15 miles from this, from College Station. So that's the 113.3. And we're going to stay at 15. If we were military, we'd also have to tune channel, or select channel 80 for the TACAN radio. Come in here to Ozumi, follow the arc, and then when you intercept the localizer course for the ILS, then you turn on that. So that's what I'm going to demonstrate, is how to stay on that arc from here to the final approach course. Then we'll fly it in and we'll touch down. So if we go back to the map, let's show you where we are. This is the IFR low chart. I'm going to be on Victor 565, which is the 249 radial, and I'll show you that inbound. So if we're flying from Georgetown, we can go direct to Skull, get on Victor 565. Oh, look at that, there's Ozumi. So the reason you have an arc is if you're trying to get from one of these airways, which are like skyways, highways in the sky, you get to that, you make your right turn, 90 degrees, and then you come around. Why is it 90 degrees? Well, you're making basically an arc, which is kind of like part of a circle. And you're flying tangent to that arc so that you stay at the same distance. It's like if you have a compass, you've got a pointy part and a pencil part. Well, you're the pencil, so you're tracking around. And in order to track along that, if you made an imaginary line between your pointy part and your pencil part, your line is going to be 90 degrees from that. So that's why we turn 90 degrees. When do we want to turn? Well, it depends on your ground speed. Figure out your miles per minute. So like 120, that's 2 miles a minute. 90, that's a mile and a half. Figure out how many miles per minute. You're going 90 degrees, so standard rate, that's going to be half a minute, 30 seconds. So you go standard rate, 30 seconds, half of whatever that ground speed per minute is, that's when you should probably start the turn. Also, might want to take like 0.2 off of that because you're not still going. As soon as you start turning, your forward speed toward Ozumi is going to slow down. So I'm expecting probably 0.5 to 0.7 nautical miles from Ozumi. I'll start the right turn. So we're going to start it with just the basic instruments, and then I'll show you what you can do if you have a fully functional set. So we're going to tab back over to our friend X-Plane. So on the map, I'm currently paused We are just outside of Ozumi. Ozumi's right about there, and we're going to come in. Unpause it. Go a little crazy for a second. It's also probably loud. Stand by. Oh yeah, I definitely need to take that down some. Well, I'll take that lower than my own voice. How about that? Let's try that. Click. Ay, ay, ay. Pause. I'm guessing that's not quite as bad. It's pretty loud in my ears, but whatever. So I'm going to pause again. Whew, there we are. Because I want to make sure everything's set up. So as you can see, the 110.55. Oh, I just had it. Come on. That's this. So the localizer's in here. The other setting is the College Station VOR. So I'm going to set it up so that I've got the VOR primary. I'm going to go to CDI and twist that 249 course. Could just hold it down, I guess. There it is, 249. But that's the localizer. Have I mentioned I'm a genius? There it is, 249. Good, good. We're still on it. Okay, we're at 3,000 feet coming in, and we're following the 249. But wait, you ask, how do I know how far I am from Ozumi? Well, that's easy. I hit PFD, and then I click DME, and there it is, 113.3 CLL. And I'm also going to change that to NAV2. So NAV2, which is the same thing, CLL, is telling me how far out I am. So 19 miles. So we still need to go 4 miles before we make the turn. Maybe 3.5. We're going 112, so 3.2. So we'll make our right turn at roughly, oh heck, 15 point something. 15.6. Give it a little bit of trim. Come back to the right. Now, what if they say cross Ozumi at or above 2,000 feet? Well, I can start our descent, if that's the case, down to 2,000. So I'm going to pitch down, trim to hold it, and reduce my power. 1,000 to go. There's no wind, so completely unrealistic, especially for today. We were having some robust winds. We're getting there. There's 16.7. Going back slightly to the left. I don't want that much correction. Okay, and there's 16. 15.9, 8, 7, starting my turn. Going right, about 15 to 20 degrees, and when this magenta line gets to the second line here, that's the standard rate turn. It's a trend line based on where you're going to be in, I think, 20 seconds. It's in the book. I haven't looked at the book. All I know is that second line, that means standard rate turn. I'm talking to nobody, but that's all right. My egregious lack of a thumbnail, I'm pretty sure that's what it is. So I want to start my turn to the right, 90 degrees, and as you can see, we're coming up on 15 already. So I'm going to start my rollout, and 100 to go. Okay, and I am going to twist 10 to 240, and I'm going to turn 10 to the left, and we'll hold 15. Raise my nose, add some power, and we'll go up to 2400. Okay, so we're 0.1 inside the arc. Actually, we're a little more than that, so I'm going to hold 15. And now we're climbing. Try not to make jerky movements, but I can't tell I'm making jerky movements because it's not a real airplane. But don't tell my computer that. I spent a lot of money on it. Okay, there's another 10, 230. Climbing, correcting. And we're at 14.8. So this is kind of dull, you know. I don't want to turn outside the arc, but if I go inside, I just want to hold the same heading until I eventually get back onto the arc. All right, we're about to come through the 230 radial. We are still climbing, and it's starting to get annoying. I'm going to initiate the descent with the trim. Okay, there's another one. Okay, we're almost up to 15, so twist 10 and still hold 15. So the idea is twist 10, turn 10. It makes a whole lot more sense if you have a traditional CDI and you can't see your heading overlaid on top of that like we have with the HSI. Okay, now I can turn 10. There we go, 140. I'm going to roll out there. I'm going to stay at 15. So it all kind of depends on what your distance is doing, whether you turn or not. You just make a decision, do I need to turn 10 or not? If I'm a little, if I'm right on 15, then yeah, the next time I twist 10, I'll also turn. And it works for the analog systems. But you're probably thinking, oh, there's got to be an easier way. Even if you don't have GPS, there's got to be an easy way. Well, there is. Let's introduce you to our friends, the bearing pointers. As you can see, we have a bearing pointer for nav1, CLL. It's telling us we're 15.1 miles. And nav2 is telling us the same thing. Nav2 is this double line, and nav1 is the single line. So, do I really need nav1? Not really. I've got two different ones. So what I'm going to do is I'm going to put the ILS localizer course in nav1, which unfortunately means I have to, because it's an X-plane thing, I have to put the 346 course in it. So it's the other way. 346. So we're going to have 346 in, localizer 1. That center line is going to go away because we don't have a signal. But I'm going to put nav1 listen up so that when we do get the signal, we know it. And when I unpause it, there it goes away. Well, that's interesting. It is making a noise, but so what we have here, as you can see, is a bearing pointer that always points in the direction of the station. So if you're thinking what I'm thinking, all I need to do is keep myself 90 degrees to it. So I'm going to turn so that this pointer points at this little 90-degree tick mark to the left. That's why they put those tick marks there. So if I initiate a little turn, like so, in fact, I'm going to give it an extra 10 degrees above the little white line. Descending, correcting. There we go. Oh, there's, okay, I went too far. So that's okay, we just take some of that out, and we continue flying the arc. Now, if you look at the difference between the blue double line and the green line, that's about how many radials I have to go, give or take. They're not based on the same thing. As you can see, the arc is based on this device here. The center line is based on the runway itself, the localizer, which is on the near the runway. All right, so I'm letting it drop down, and as it drops down, as you fly straight ahead, it's going to increase, and the head of the needle is going to fall because the nav aid is passing to my left and behind me. So as I go forward, it's going to indicate that. And also the tail of the needle is going to climb up. And in our case, for this approach, the tail of this needle will actually go through the localizer course. But that's roughly the time that we can start ignoring the tail of the needle. But the important thing is not where the needle is pointing. The important thing is this number right here, or this number, no, this number right here. Incidentally, in reality, you're not going to have this number if you have a localizer selected. This 16.4, for some reason the G1000 will not give you a distance from you to an ILS DME transmitter. It'll give you a distance from your present position to a nav aid because it knows the locations of all the nav aids and it knows where you are according to the GPS. So it'll put a number here. It's not based on DME. It's actually based on your ground distance. DME is your straight line distance, the hypotenuse of your little triangle. So this number will usually be larger than this number, but this number is more accurate. All right, so we're at 15. So now I just want to put a nice gradual turn in to get that straight, and now we're flying the arc like no problem. One caveat though, however, unfortunately you're not going to be in a no wind situation. So if you have a wind blowing you away from the transmitter, you got to keep that needle up above the white line, and same if it's blowing you toward the transmitter, then oh gosh, yeah, then you've got to let it dip below the line. All right, unpausing. So I'm going to fly it the rest of the way using this method. First place I learned this was actually the Air Force. So as a navigator, I didn't have my own HSI because I didn't need one. I wasn't flying. But I did need situational awareness on what the pilots were doing. So what they had was, they call them BDHIs, or if you're an older pilot, you may recognize the name RMI. RMI is radiomagnetic indicator, and BDHI is bearing distance and heading indicator. So this is actually what we have, is BDHI. So it shows the bearing to the station, and it shows the distance from the station, and it shows your heading. We also have a horizontal situation indicator, being the HSI, of course, but this is just a little extra perk. So I've gone a little bit inside, so I'm just going to let that needle drop down. It's no big deal. I mean, if you're holding within half a mile, you're golden in my book. There it is. There's 15. I'm going to turn again, just like half standard rate. And roll out. Roll almost all the way out. And as you can see, our radials are getting closer and closer to the localizer course, but we're probably not going to start picking up the localizer course until we are 90 degrees to the localizer. And that's what it shows up here. You're about 90 degrees to the localizer before you start turning inbound. And there it is. While I was away, it popped up. Now I'm slightly inside, so I'm just going to fly this heading. And what I'm looking for in this case is for this this course line to come down to this. Normally this is the 4-degree mark, but since it's a localizer, it's more sensitive to that. I don't remember whether it's twice or 4 times as sensitive, but it could be 2 degrees or it could be 1 degree. But from this distance, it's fine. I continue slowly turning toward it, even if I'm slightly inside. And now they're both showing that I'm 15 miles away, give or take. Even though they're not from the same source. And don't worry, I am going to look out the window when it is time to land. I'm not a fool. So we're just going to hang out. Few more seconds. You can see the tail of the needle is now passing through to where we're on the same radial, or we're on the same course to the station that the localizer is. So we're kind of parallel to both. And we're at 15, so I'm going to turn to get the blue needle back where I want it. But as you can see, this is a lot less work than turn 10, twist 10. I don't have to keep twisting. I can just turn based on what my DME is telling me. Glide slope is alive. And we're just about, we are just about perpendicular to our localizer course. I expect it to be coming in any minute now. We're going 113 knots. You actually start picking up the course roughly the 30-degree mark. So it could still be a little while. But we continue arcing. We don't have to intercept at a 90 degree. That would be insane. Well, I finally got a really good trim going. I'm happy with that. Simulators are always harder to trim than airplanes because you have to sort of imagine your own back pressure on the yoke. It's coming up, it's coming up, it's coming up. There it is. Center line's alive. I'm going to make a standard rate turn to the left. Maintain my altitude. Hopefully I don't go through the center line. Oh, so glorious. Look at that. And I'm descending. Bad instructor. That's a bad instructor. You apologize. I'm sorry. Okay. We're on center line. We're done with the arc. So that's how the arc works. And you can see nav2 bearing is still pointing off to the left where the College Station VOR is. Now, normally I'd probably slow down below 105 knots at this point because you don't really have to go en route airspeed onto your final approach course. However, I don't want this video to take all day. It's not like YouTube doesn't have literal petabytes of data ready to go for creators, but still. Yeah, we're all right. I just make very slight adjustments. I'm still going full mixture. I could pull that back and save some virtual gas. Whoa, let's listen to that engine race. Alright, so you'll learn this in other videos, but the method I was taught for Cessnas doing instrument approaches is when you get to where your glide slope is 1 dot above you, in other words, you're 1 dot low, or you're 1 mile from the final approach fix, depending, you're going to configure. You're going to reduce your power to a power setting that's going to get you to 90 knots. For the Cessna, it's about 2100 RPM. Or if you're in a comparably equipped plane with a constant speed prop, I'd say probably 21 inches of mercury. Manifold pressure. Reduce to that, then add 1 notch of flaps, whether it's 10 degrees or 15, whatever your airplane normally accepts. And then stabilize at 90 knots. And then when your glide slope gets down to that little white line right there, then you're on the glide slope. So I tried this yesterday. It was a little janky, but I haven't flown an actual instrument approach from the left seat in a little while now, so kind of excited. This is good for my own proficiency. X-Plane is really good. It flies like the real thing. Microsoft has better graphics, but the flight model is, it feels like you're flying an Xbox. Not that there's anything wrong with that. It's still usable, but now we're at the final approach fix. So I'm going to pitch down 2.5 degrees, maybe 3. Keep myself at 90 knots, so I'm going to add the power. 1900 usually does the trick. I'm very slightly left of course, so I'm going to come back to the right. So now my eyeballs are sort of making a triangle. I'm saying airspeed, glide slope, course. By the way, the minimum is 511, so I'm going to be looking for that manually or ocularly. There we go. We roll out very slightly high, lower the nose. I find if I'm high, I go down to 5 degrees nose down, and if I'm low, I go to 0 until I've fixed it, and then we figure out where to go from there. Let's just keep 5 degrees nose down. We're still well within tolerances. 1 dot high or low is it's pretty good, preferably high. You don't want to go low for very long. Reduce the power very slightly. As you get to lower altitudes, your air density is going to get higher, so your propeller's more effective and you produce more thrust for RPM. Alright, so we're about 700 feet to go. Airspeed looks good. So yeah, I'm just looking at airspeed, glide slope, center line. Or, as you'll learn from me as a CFII, I like to say power, pitch, bank. Those are your 3 flight controls, and these are your 3 primary instruments for flying the ILS. All right, we're out of the clouds, but I'm not going to look up for another 500 feet. Coming back to the right, still slightly high. Rolling out. Fixing ourselves. We want about, I guess, 4 degrees of pitch below the horizon. Let's hold it there. This power setting's working for us. We're very slightly left, coming back to the right, rolling out. Let's get on the glide slope. Back to the left very slightly. Hold that nose down attitude. We're 100 above. Ooh, and it gets very, very sensitive. So I'm going to go to 5 degrees nose down very briefly. Come back up. There's minimums. And we're visual. Look at that. We're going to come in and land. Now, I want to stay on this glide slope if at all possible, but while doing so, I'm going to reduce my power to minimum, and I'm going to raise the nose. A lot of students, they don't understand the requirement that you stay on a glide path all the way to the touchdown zone. You want a constant glide path. I've only got 10 degrees of flaps. I usually like to land with 30. Alright, thrust reversers. Haha, just kidding. And we're going to come to a stop, raise the nose. Fairly simple. Go back above 800 so our voltages don't indicate a discharge, and we're good. So that's how you fly an ARC to an ILS. And that's all there is to the video. Now if you want the easy method, here we go. Go back to the map. We're going to go back to where we were before. Oh, I should have increased our altitude before doing that, because now we've destroyed numerous houses. And I'm just going to put us right at 2,000, a little above. Speed 105 and pitch 0. We're going to come out this way, and we're going to make our heading 070. And there it is. Unpause, get back to altitude and power setting. Pause again. Now I'm going to do some setting up. You're not going to believe this. So if you're ever my student or any other student or any other pilot, and you find yourself in actual hard IMC, and you got equipment like this, I give you permission to cheat. Here's how you cheat. Go to flight plan. It cleared my flight plan from yesterday? Holy mackerel. I can't go to nearest airports either. All right, well, here we go. K, C, LL. Oh, there's an L already. That's nice. Oh, no, L. Okay, little is harder than the real airplane. Easterwood Field. Enter, enter. Okay, now direct, Easterwood, activate. Procedure, select approach. Oh, look at that, ILS 35. Enter. Where do we want to start? We want to start at Ozumi, don't we? Minimums, Barrow, and I'm going to put in 511, but it won't take 511, so I'm going to put in 520. And we're going to activate it. I'm going to switch, I'm going to go back, I'm going to switch my CDI to GPS mode. And now watch this. Unpause. Now I just stay on center line. Now my bearing pointer for nav 2 is still going Oh, and I always forget this too. I gotta raise the flaps. I'm glad I didn't put 20 more degrees in like I practiced yesterday. So we're gonna stay at 2000. We're gonna stay on center line, and now this is taking us direct to Ozumi. Now in real life, I'd actually have the airway in, but we were already on the airway when we pushed direct, so is ATC really gonna know? No, but your friendly neighborhood DPE might have a thing or two to say. I'm gonna zoom in on these guys so you see what's going on. Oh dear. 100 high correcting. Like I said, the simulator, it's a little more touchy, a little more sensitive. So we're within 2 miles of Ozumi, but the GPS is going to tell me when it's good to turn, which is going to be about 0.6 from Ozumi, like it was before. There it is. So right to 064. It even tells you the heading. 5 seconds to turn. Ready, turn. Clear right. Fix my altitude. 064. Also, there it is. It's on the arrow. So now if I watch the DME to back myself up, start my rollout, I'm very slightly outside, so I'm just going to hold a heading that's slightly left of the arrow. And that center line is this curving center line all the way around the approach. So if I come right a little bit, increase my range, there's my entire approach right there. Oh, bother, I went a little high. Or as I tell most of my private students, it's okay to be a little high. That's a drug joke. Anyway, legalize it, man. Just, don't actually do it if you're going to be flying. It's in the PHAC. Alright, now we're on the course, so literally all I have to do is follow that pink arrow. And you're saying, but Ben, this is too hard, following a pink arrow. Yeah, you're right. Autopilot. I'm going to put it in nav mode, and I'm going to put it, oh, we already have the altitude captured. Normally it'll go to pitch mode, so you have to hit nose up or nose down, but not today, buddy. That's literally all there is to it. Now I don't have to trim, I don't have to, I can, I walk this mixture back. Good EGT is about 1450 normally, but I'm losing RPM if I do that, so I'm going to put it back up. And unfortunately, there's no lean mode to help you out. There is in Microsoft, but that's an actual licensed Garmin G1000 simulation. This is the X-Plane 1000 deal, which is fine. While I'm doing this, yeah, and I'm sure if I had given people more advanced warning that I was going to do this, then we'd have some people actually flying along. But yeah, this is X-Plane. Still rocking version 11. I may get version 12 one of these days. Graphics are almost as good as Microsoft, but the flight model, again, is going to be quite a bit better. I didn't want to get it right away because version 11 had quite a few bugs in it when I first got it. So they've worked all those out by now. I'm sure Since 12's been out for a couple of years now, it's probably also good. I look like the laziest pilot in the world right now. Although my feet are not up on the yoke, so I guess that says something. If anybody is watching, how would I know it? That's a good question. Well, that's not what I wanted to happen. How do I make that go away? That's dumb. Oh well. Oh man. Yeah, I don't know what so many of these things do, scenes and whatever. I just know streaming to YouTube, they don't delete your video after like 30 days. I used to be able to stream right from my my other motherboard. It had it came with whatever it takes to stream stuff. I don't know what that program is, and I changed motherboards. Huh. Interesting. Now this approach really takes a while. I could have gone with a shorter one like the VOR 1.4 into Waco. But I didn't. I wanted to do this one. So you see, we have the center line of our own, but the autopilot is keeping that same bearing pointer 90 degrees to our left. It's a little lower than that, but it makes little incremental adjustments. GPS doesn't necessarily overlay course-wise with VORs. There's a little bit of difference because GPS, as it shows on our screen, is going to be the actual, no kidding, magnetic variation that we're experiencing due to the lines of force. VORs are based on a manual magnetic variation that's set by some dude with a screwdriver who's making more money than I do. And there it goes. I mean, something else we can do. Oop, that's not right. Oh, I wanted heading. Okay. I'm going to turn the heading over to 356, I think it was. Well, I can find out, can't I? 346. I'm 10 degrees off. The nerve. There it is, 346. And I'm pretty sure this is going to turn us based on the GPS. I can also click approach mode. So glide path and VOR, I guess, or glide path and nav are armed now because it's got the, or is it glide path vertical speed? I don't know what the GPV is. But since I've got an autopilot holding my altitude, I can go ahead and reset my bug. Oh, it doesn't, it's not going to stop at 520? Oh, there it goes. In real life, if you twist the big knob and you've got something set up like a minimum or if I come over to here to flight plan and tell it I want to be at a particular altitude, it'll actually set up the vertical nav profile down to that altitude, and it'll it'll click to that automatically. And I like to have it in flight plan mode when I'm en route, because I also like to zoom in enough that you can see the airport diagram if you have safe taxi enabled. So you have the airport diagram on the full map screen, and then as soon as you take off, you can go to flight plan mode, and it zooms you out to whatever zoom setting you had the last time you used flight plan mode. So it's a real quick way of going from, you know, zoomed out en route to, oh, I just landed, I need to know where to go. Click flight plan again, it goes away, and now I have my taxi map. And I think I had a... Nope, everything's good. I still get notifications on my phone. I have no idea what they are. It's the same noise that it makes when I get a text. But you didn't get into this stream to hear about my problems. Looks like nobody got into this stream at all. I could have YouTube open in a separate window to see if anybody's actually watching. But I don't know how to figure that out from just from this. If anybody is watching, if you don't mind, go ahead and send a chat message. Even if you're a bot, whatever. So another thing, the real airplane is going to automatically switch when it transitions here from GPS mode to localizer 1 mode. I'm going to leave it alone and let it turn onto the GPS course, and if it hasn't switched, then I'll switch it manually. Left to 346 in 10 seconds. 5 seconds. Ready, ready, turn. It is not going left to 346, so I'm going to click, nope, click CDI, click approach, approach again. Yeah, there it goes. Oh, now it decides to turn. Okay. So maybe, for sake of the simulator, maybe I should have pushed the button when it first said 10 seconds to the turn. Because it probably would have intercepted properly if I'd done that. It shouldn't take a doggone rocket science degree. Alright, so I put it back on altitude hold. Well, 2000. Put it in pitch mode. Nose up until it gets back to 2000. There it is. Okay. Now, glide slope is armed. So I'm going to change the altitude back down to 520. Which you don't have to do. It's just that way it won't beep at you. It'll beep at you when you're 1,000 to go. It may flash at you when you're 200 to go. But it's not going to level off. Now, something that this airplane apparently doesn't have, that normal Cessnas do have, if they have an autopilot, there's a little button to the left that says GA. That's the go-around button. And what's supposed to happen if you push the go-around button, which on this, I have the Bravo throttle quadrant from Honeycomb, not sponsored, but if they want to throw money my way, I have to say the YouTube thing. Like and subscribe, but if I want to go around with like one of these types of planes, I just hit this button on the side of the control, and it should execute the go around for me. What that means for the Cessna, if you hit the go around button, which is just to the left of the throttle, it will go into flight director mode. It kicks off the autopilot. Your flight director indicates a climb about 7.5 degrees, which is this third line from the bottom. It's the little line right below 10, 7.5. That usually gives you a good climb rate, you know, pretty close to VY if you do that. It automatically selects that. It activates the missed approach procedure in the GPS, and then it flies the missed approach. So we're screaming along at 110 knots. When the glide slope comes down to the 1 degree up mark, which it's almost there, 13 seconds to the descent, okay? I'm going to pull the power back to 2100 and add 1 notch of flaps. Autopilot is going to pitch me down to hold 2,000 feet. Ahem. Well, whatever. Alright, there's 90 knots. I'm going to bump the power up just enough to hold 90 knots. And that's all I have to do. Sometimes in a descent, even a gradual one, you'll have an opposite P factor. So your ascending blade is at a higher angle to the relative wind because your nose is pitched down than your descending blade, which is the opposite of what happens when you initiate a climb. So your airplane is going to want to yaw slightly to the left, right, so you may have to add left rudder to make a coordinated descent. But, I mean, this is how the airline people do it. They plug the whole thing into the navigation system. They have an FMS, a flight management system. We have an FMS knob that does the flight management system functions. Airspace near and ahead. Actually, we're inside the airspace. The airspace it's talking about is the lateral and vertical boundaries of the class Delta around Easterwood Field. Alright, so we've descended, which means the air density has gone up a little bit, so we don't need as much thrust to hold 90 knots. So I'm going to pull back the RPM by, I usually go for 50 RPM if it's 5 knots, 100 RPM for 10 knots. It's what we call a WAG, a Wild Aggie Guess. Ha! That's appropriate because we're going into College Station. Yeah, so on a day like the one we're simulating, it's 1940. Now to kick off the autopilot, there's usually also a button right here on the control wheel. I have my control wheel right here. I don't know if you can see it in frame. But there's usually a little trigger button. Actually, it's up here. That if you push that, it kicks off the autopilot and makes a horrible noise. There's 512 on our way down to it. And for this procedure, we're just gonna take over manually right at minimums. There's some airports you don't get to do that. Drawn Miller in Temple, Texas. You have to kick the autopilot off a little bit higher. I don't remember how high. But it's on the approach plate. I would just read the approach plate. Alright, coming up on minimums. Going back to default view. Visual, autopilot coming off. Flight director's coming off. Barely touch anything. And I'm just going to reduce the power while raising the nose slightly. I'm going to go power to idle, actually, because we're coming in at a pretty high speed. Now, if I reconfigure, now I've also got to pitch down. Arguably, that takes you from a stabilized approach to a less than stabilized approach. But to each their own. I don't like to use up giant runways if I don't have to. But if I've got a DPE on board, I'm absolutely going to stay on that glide path and so on. So those are all the different methods of doing it. I may do another video in a couple of days. Use the analog equipment in case anybody, in case there's overwhelming demand for me to show that that procedure as well. But yeah, that's the end of the stream. It's I don't even know how long it's been going. Like I said, I'm new to OBS. Oh, 1 hour, like pretty much on the dot. All right, cool. Well, that's it. Take care.